Hi, welcome back to Quantitative channel. I'm Jaco Wong. Today we are going to look at MRSM, Paper 2, Section B and C. Question number 7. Diagram 7.1 shows the structural formula of a chloroethene or vinyl chloride, which can be used to produce a synthetic polymers. There is a PVC, polyvinyl chloride or polychloroethene. Okay, so this is a structure, monomer of it. So state the polymer form and write the chemical equation. So here, actually the polymer, just now I mentioned already, we just add in a name, the terms poly in front of it. So 2 marks. So it can be polychloroethene, ethane, or polyvinyl chloride. Okay, next will be chemical equation. So chemical equation, so we need the C2H3 Cl. Okay, so it will form the C2H3Cl times M. Okay, so we need the N. Okay, so now I show you you can write like this, or you can draw out. So the initial one will be C, okay, like this. We follow the one, so chloride is here. So this is the monomer, so times N. So after the polymerization, the double bond is gone. Okay, times N. So you can choose write like this, or you can draw out the structural formula. Okay, so this is how to form the polymerization of polyvinyl chloride. Okay, next question. Explain how the usage of synthetic polymers substance can cause the environmental pollution. So in your explanation, include the following aspect: the source, process, and then the effect. So 3 marks. So here, actually, this question got a few options. So I show you few of it. Okay, number 1, we use the, let's say, PVC now. Okay, let's say condition 1. Okay, so 3 marks. Okay, synthetic polymers. Okay, synthetic polymers, for example, you can give a PVC, polystyrene, nylon, and so on. Okay, are non-biodegradable. Okay, non-biodegradable means cannot decompose by bacteria. Okay, so they will cause the blockage of drainage system, and then or it will cause a flash floods. Okay. So another one, okay, if burning of the synthetic polymers, okay, of synthetic polymers, okay, if burning, okay, will release the poisonous gases or toxic gases. Okay, for example, sulfur dioxide, okay, carbon monoxide, chlorine, hydrogen chloride, and so on. Okay, then these poisonous gases, okay, this gas can dissolve in rainwater, right? Rainwater to produce acidic rain, acid rain, okay, acidic rain, okay. So it will cause you increase the acidity, okay, of the soil or lake, okay, or river, okay, and then it also corrodes the building, right? Okay, corrodes the building. Okay, so these are the example of side effect of the acid rain to the environment. Okay, beside that, you can also write about the greenhouse effect, okay, but here I just show you two example how you can write your answer for this question. Okay, B, diagram 7.2 shows the bicycle's wheel rim made from two different materials. The iron rim is easily bent, whereas the alloy rim does not easily bend. So meaning that the alloy one will be harder, okay, harder. Okay, so you can see the arrangement of the atoms. The types of the atoms in the iron rim are all from the same size or are iron, same size, same type. Okay, so it will arrange in orderly arrangement like this. Okay, this is the alloy. So alloy, it has a different type of atoms. Okay, so different sizes. So the arrangement is the orderly arrangement of the atoms are disrupted. Okay, so based on the diagrams, explain in terms of arrangement of atom and why alloy ring is better than the iron ring. Okay, so 5 marks. So meaning that 5 points. So we can write in 5 points. Okay, so we can write point number 1. Okay, we can write is alloy rim is harder. Is harder than iron rim. Okay, this is the first point. Okay, point number 2. After that, we can write in iron. Okay, iron atom are same sizes. Okay, same size. Okay. Okay, you can mention and arrange in orderly manner. Okay. Point number 3, we can mention in alloy rim. Okay. The presence of carbon atom, right? Okay, carbon atoms of different size. Okay, you can mention about the different size. Okay. Point number 4, disrupt the orderly arrangement of iron atoms. Okay. So point number 5, the layers of cannot slide easily. Okay. So actually you can write in a full sentence. Like the point number 3 and point number 4, you can write together, but you will get 2 marks under these 2 points. Okay. So in the exam, you are allowed to write like this, so easier for the marker to give the marks to you. Okay. And then for you, you also can see how many points you have written. Okay. Now C, following equation show the decomposition of copper 2 nitrate. State the quantitative information can be deduced from the equation, and then after that calculate the volume of gas, oxygen gas, if 3.2 gram of copper 2 oxide is produced. Okay, so here quantitative information, okay, so refer to the quantity, quantitative. So normally we will mention about the number of mole. Okay, yeah, so there are 4 marks here. So point number 1 we can mention is the quantitative. Okay, we just mention whatever inside the equation here. So 2 in front means 2 mole of copper 2 nitrate. Okay, so in this one, decompose, right? Decomposition. Okay, you can just write produce. Okay, or you can mention decompose to form 2 mole of copper 2 oxide, 4 mole of nitrogen dioxide, and 1 mole of oxygen. Okay, so this is how we write the quantitative information. Okay, then point number 2 we can write is the calculation number of mole of copper 2 oxide given to you. So given to you is 3.2 over the molar mass for the copper 2 oxide. So copper 2 oxide is 64 plus 16, so it's 80 over 80. Okay, so you will get 0.04 mole. Okay. So what is the volume of oxygen gas? So here oxygen gas we have to compare. So point number 3 we need to compare the mole ratio. Okay, 2 mole of copper 2 nitrate produce 1 mole of oxygen, right? Okay, so here if 0.04 mole of copper 2 nitrate, so you produce half, right? Half, so meaning 0.02 mole of oxygen. Okay, so point number 4, need to find out volume of oxygen, right? Okay, volume of oxygen, so you get mole times the molar volume. Okay, molar volume is 24, right? 24. So mole is 0.02 times 24, so you will get 0.48 cubic decimeter. So this is the diagram shows the apparatus for 2 experiments to determine the empirical formula for magnesium oxide and copper 2 oxide. So in the SPM level, again, empirical formula, we have two methods here, method 1 and method 2. Okay, so how do we determine which method do we use? So I provide a reactivity series here. So actually you can just refer here. Okay, so this is a location of the hydrogen. Okay, so the metals below the hydrogen is called, we can assume it is an unreactive metal. So we will use this apparatus to do an experiment, use the hydrogen to displace metal. So the most common will be the copper, because copper is here. So beside that, you also can use the lead, tin, iron, also can be used this method to produce to determine the empirical formula. Okay. Meanwhile, for the metals that is above the hydrogen, like zinc, aluminum, magnesium, okay, we will use this apparatus to use it. Just heat directly in the crucible to react the metals with the oxygen. Okay, yeah. So this is for method 1 is for the reactive metal, the metals above hydrogen in the reactivity series. Okay, then for experiment 2 is the metals below the hydrogen in the reactivity series. Okay, now write the chemical equation occur in the experiment 1. So magnesium react with the oxygen, so produce a magnesium oxide. So magnesium oxide, we need to balance the equation. So oxygen 2, okay, so oxygen becomes 2, then magnesium times 2, so this one times 2, so it's balanced equation. So explain the differences in the method used for the determination of the empirical formula for both oxides. So 4 marks. So just now I mentioned already the reason. Okay, so point number 1, what we can write is, okay, point 1, okay, magnesium is a reactive metal. Okay, then magnesium, point number 2, is easily react with oxygen to form magnesium oxide. Okay, so next point we can mention about the copper. Copper is unreactive and unreactive metal, okay, or you can say less reactive than hydrogen. Okay, So point number 4. So hydrogen can reduce the copper 2 oxide, okay, to form copper. Okay, so this point 3 and point 4, let's say it use the lead metal also can, so as long as below the hydrogen. Okay, yeah. So popular example they will use in the exam will be copper and the lead. Okay, diagram 8 shows the information about the jelly sting. Jellyfish has a tiny stinging cells in their tentacles to stung or paralyze their prey before they eat them. So alkaline jellyfish stings can be painful to humans and sometimes can be deadly. Okay, so we know that the jellyfish stings is alkaline. Okay, so suggest one substance that can be applied to skin to relieve the pain of the jellyfish sting without causing the further injury. Give 2 reasons for your suggestion. So just now we know that the stings will be alkaline, right? So we have to choose some things that is acidic to neutralize the stings. Okay, so point number 1. Okay, we can use what? We can use the vinegar. Okay, it's the best, or ethanoic acid, or acetic acid, or lemon juice. Okay, or any suitable weak alkaline. Okay, so give a reason why you choose vinegar, because the hydrogen ions from the acid can neutralize the alkaline. Okay, the alkaline. And then why we choose the vinegar? Because it is less acidic. Less acidic. We cannot choose the strong acid for this case. Otherwise, it will cause it will harm or destroy your skin. So we cannot use the strong. Okay, B table shows the concentration of volume of 2 different types of strong acid, X and Y, which are used to neutralize 20 cubic centimeter of 0.5 mole per cubic decimeter potassium hydroxide solution. So potassium hydroxide is a strong alkaline. So concentration the same, but the volume used to neutralize the alkaline is V. This is 2V. Means this is double, meaning that this acid will be diprotic acid. This one is monoprotic acid. Okay, so based on the information, suggest acid X. So X can be sulfuric acid. Okay, and Y is nitric acid or hydrochloric acid. Okay, so write the chemical equation for the acid X in the B1 with the potassium hydroxide solution. So it's sulfuric acid react with potassium hydroxide, KOH. So it forms a potassium sulfate and water. Okay, so we need to balance the equation. This one times 2. Okay, then the water also times 2. Okay, so this is how we write the chemical equation. So 2 marks. So a group of students doing experiment between acid and alkaline. They notice that the label of 2 substances are detached from the bottles. So meaning that it's gone. Okay, describe one chemical test that can be used to verify the acid or alkaline for both bottles. So 4 marks. Actually, we can determine whether it's acid or alkaline. Okay, the easiest way is use the indicator, but we cannot use the indicator for this question because the question mentioned is the chemical test. Chemical test. So chemical test, we cannot use the indicator to determine it. Okay, so we can use the metal or metal carbonate, okay, to determine whether it's acid or alkali. Okay, so for example, let's say we use the metal first. Okay, so first one we pour, okay, let's say 2 cubic centimeter of let's say the acid and alkali for each solution into 2 test tubes. Okay, and you can label X and Y for example. Okay, then point number 2, we can add in, okay, let's say 1 gram. Okay, 1 gram, 1 gram, sorry, 1 gram of, let's say, zinc. Powder into both test tubes. Okay. Point number 3. Okay. If bubble gas are released, okay, meaning that an acid is present. Okay, then if no change and alkaline is present. So from here we can determine whether it's acid or alkaline is present. Okay, so this is the easiest way. Beside the metal powder, we can also use the metal carbonate. Okay, metal carbonate like zinc carbonate or calcium carbonate. Then if acid, you will release the carbon dioxide gas, then you will see the bubble gas. If no change, so alkaline. Yeah. Okay, diagram 8.2 shows the apparatus for the experiment to determine the heat of neutralization. Heat of neutralization. So you can see volume, concentration the same. This is sodium hydroxide. This is hydrochloric acid. Okay, so the reaction mixture. Then we measure the temperature. Okay, so initial temperature is X for hydrochloric acid. Sodium hydroxide is Y. Sorry, is 28. Highest temperature reach will be Y. Okay, so you can see here, graph shows the temperature measure in the plastic cup. Okay, before and after for the sodium, after mixing with sodium hydroxide. Okay, so meaning that this is temperature. So this is 28. So the highest is 40. This is 40. See, 40, 45. So 40, 41, 42, 43. So here is 43. The highest. Initial is 28 now. 28 here. 35 seconds, we reach the highest. Okay, so temperature X and Y. Okay, so temperature X will be, let me see, here is, here it should be 29, 29, not 28, here is 30, sorry. Yeah, this graph actually not very clear, it should be 29. Okay, so X is 29 degrees Celsius, so Y is 43. Okay, then after that we calculate the heat of neutralization for the reaction. Okay, so there are 6 marks here. Okay, so first we can calculate the number of mole first. Okay, number of mole. Mole for both acid and alkali are the same. Okay, are the same. Sodium hydroxide or hydrochloric acid, they are the same, so we can calculate HCl or sodium hydroxide, same. So we use the MV over 1000. So MV over 1000, M is 2, V is 50 over 1000. Okay, so you'll get 0.1. Okay, so for both acid or alkali the same, so we can use any one of these. Okay, then after that we can calculate Q equals to mc theta. M is the mass for the solution, both solutions, so will be 50 plus 50 times C is 4.2 here, times the theta. Theta is 43 minus 28. Okay, so use your calculator, you will get 28.29. Okay, sorry, here we have to initial temperature for the acid is 29, for the alkali will be 28. So 28 plus 29 over 2, so you get 28.5 degrees Celsius. So is 28.5. Okay, yeah. So we use your calculator, you get the value is 6090 joule, or you can change to kilojoule, 09 kilojoule. Okay, so after that we can calculate the delta H, heat of neutralization. So you'll be Q over the mole. So Q is 6.09 over 0.1, so it will be 60.9 kilojoule per mole. Okay, yeah. So the heat of neutralization is negative 60.9 kilojoule per mole. Okay, so negative shows the heat is released, is an exothermic reaction. Okay, yeah. Now predict the heat of neutralization if the acid used is replaced with the ethanoic acid. Explain your answer. So ethanoic acid is a weak acid. The heat of neutralization is lower. Okay, why? Because P2, point number 2, the ethanoic acid is a weak acid. Okay, it's a weak acid. Okay, it ionizes partially in water to produce low concentration of hydrogen ions. So point number 3, some heat release during neutralization is absorbed by ethanoic acid molecule. Okay, to ionize completely. Okay, so that's why the heat of neutralization will be lower. Yeah, same case happened to ammonia. So weak alkaline, also the same. As long as it is weak acid or weak alkaline, so it will be lower heat of neutralization. Okay, now we look at question number 9. Okay, ionic compound is formed when the group 1 elements react with group 17 elements. By using the suitable example, so explain how the formation of bonds can be formed. So 4 marks, so at least 4 points. So we can use example of sodium and chlorine. Sodium electron arrangement is 281, chlorine is 287. Okay, so 4 marks, 4 points. So point number 1, you can mention the electron arrangement of sodium is 281 and chlorine is 287. Okay, then point number 2. Okay, then for sodium atom. Okay, sodium atom will donate or release 1 valence electrons, okay, to achieve stable octet electron arrangement, okay, form sodium positive, 1 positive ions. Okay, then point number 3, we can mention about the chlorine. Okay, chlorine atom, okay, will be receive 1 electrons, okay, to achieve also octet, stable octet electron arrangement, okay, form Cl minus ion, chloride ions. Then point number 4, okay, sodium ions and chloride ions are attracted by strong electrostatic force to form ionic compound of NaCl. Okay, so these are the 4 points you can write for the formation of sodium chloride. Okay, next. Okay, diagram 9.1 shows the chemical equation for the reaction 1 and 2. So reaction 1, you can say Y plus copper 2 sulfate. So okay, so this one we know it is a displacement reaction. Okay, reaction 2, lead 2 nitrate with sodium sulfate forms a lead sulfate and sodium nitrate. Okay, so this is a precipitation reaction. Okay, yeah. So based on the chemical equation, so suggest metal Y. So metal Y it can displace the copper from its solution. So you can choose any more electropositive metal in the ECS compared to copper. So you can choose any one. Okay, so 1 mark. So you can choose, let's say, zinc. You can choose magnesium. Okay, you also can choose aluminum. Okay. Next, determines whether the reaction 1 and 2 is a redox reaction. Explain your answer. Okay, so 5 marks. Okay, so let's see. Reaction 1 is a displacement reaction. So displacement reaction, yes, it is a redox reaction. Precipitation is a non-redox reaction. Okay, now we explain why. Okay, so for 5 marks. So here, okay, let's say we write point number 1. Okay, reaction 1 is a redox reaction. Okay, so you have to explain why it is a redox reaction. Okay, so here actually I can show you. Okay, the first one is the displacement. Okay, so let's say Y with copper 2 sulfate. So it forms Y sulfate and copper. Okay, so now we can actually determine the oxidation number. So here oxidation number, it will be 0, 0. Okay, then the Y sulfate actually is the +2. Okay, then here copper is +2. Then finally it turns to 0. So you can see the Y oxidation number is increased from 0 to +2. So oxidation. Copper 2 sulfate is the reduction. Yeah, +2 to 0. Okay, so we can explain point number 2. Okay, so oxidation number of Y increase from 0 to +2. Okay, then point number 3. Okay, oxidation number of copper decreases from +2 to 0. Okay, so it undergoes a reduction. Okay, so you can say here is oxidation, this one is reduction. Okay, next point number 4. Reaction 2. Reaction 2 is non-redox reaction. Okay, why? Because all the oxidation number for all the elements remains the same. Okay, because the oxidation number of all the elements remains unchanged. Okay, why? Let's see this example. Lead nitrate, sodium sulfate. Okay, lead nitrate, sodium sulfate, so forms a lead sulfate and sodium nitrate. Okay, so let's see the oxidation number. So lead is +2, sulfate -2, this one is +1, -1. Okay, so you can see this one leg also plus 2, sulfate minus 2, plus 1, minus 1. So you can see all the elements, okay, the oxidation number remains the same. Okay, so precipitation reaction is a non-redox reaction, and then same goes to neutralization, also non-redox reaction. Okay, C. Diagram 9.2 shows the reactivity of 3 metals when react with oxygen, so magnesium, iron, and copper. So the trend is decrease in the reactivity series, reactivity with the oxygen. So as a chemistry students, describe an experiment to investigate the reactivity of metals towards oxygen by using all the apparatus and chemicals given below. So potassium manganate 7 powder, magnesium powder, iron powder, copper powder, boiling tube, Bunsen burner, glass wool, and asbestos paper. So your answer should include the procedure and observation. Okay, now I will show you a video on how to do this experiment.
Let's do a lab activity to compare the reactivity of metals with oxygen series of metals.
So you can see when the oxygen is react with the metal, so we can see whether it's burned or not. So if aluminium burns very rapidly with a bright flame, then meaning that it's quite reactive. But if copper is only glows faintly, so it's less reactive. Okay, you can see if it can burns means it is more reactive. Okay, yeah. For example, zinc, it can burn quickly. So it means
this arrangement is called the reactivity series.
Okay, so based on the reaction of the metals with the oxygen, so we can arrange like this. So arrange it into the reactivities series. Okay, so based on the video just now, okay, we can start to write our answer in terms of procedure and observation. So 10 marks. So we start from the procedure first. Okay, so first point, okay, we can put 1 spatula of potassium is placed in a boiling tube. Okay, so after you put it there, okay, this one as a source of oxygen, okay. Okay, so point number 2. The boiling tube is clamped horizontally to a retort stand. Okay. Okay, after that, the glass wool is placed in the boiling tube. After that, okay, 1 spatula of, okay, let's say now we start with the magnesium powder. Is place. Okay, We put the metal powder in a piece of asbestos paper and then put into the boiling tube. Okay, so after that we can start our heating already. Number 5. Is heated strongly. Okay, we need to heat the metal powder first before we heat the potassium manganate 7. Okay, why? Because if the metal is not heated, okay, when the oxygen comes, it won't react. So we must heat the metal first. Okay, then we heat the potassium manganate 7. Okay, then once this is the potassium manganate 7 is heated, then you will release the oxygen, and then it's passed through the hot magnesium powder. So from there we can determine, we can see whether it burns or not. If it burns, meaning that it is reactive. If it just glows only, means it is less reactive. Okay, so observation is recorded. Okay, then after you record it, repeat, right? Okay, step 1 to 7 is repeated using another 2 metals. Here is the iron and the copper. Okay, so 8 points you can write. Then after that we need to include the observation. Observation we can put into a table. Okay, so we can put in the metal. There are 3 metals we need to use, right? Okay, then we can write in observation. Okay, so metal we have magnesium. So magnesium, we know that it is the most reactive, right? Okay, so it burns. Okay, vigorously. Vigorously, you must write it correctly. It burns. Okay, vigorously with bright flame. Okay, then followed by iron. Okay, iron is glows brightly, not burning. Okay, finally is copper. Copper is just glows, glows faintly. Okay, or dimly. Okay, so here 8 points, then 9, 10, 11. So maximum is 10 marks. Okay. Okay, question number 10. Table shows types of rubber and their properties. A, more elastic, high heat resistant. B, less elastic and low heat resistant. Okay, so based on the properties given here, we can assume that A will be vulcanized rubber. Okay, vulcanized rubber. Okay, B will be unvulcanized rubber. Okay, unvulcanized rubber. So based on the table, identify the type of rubber AB. Okay, explain the difference in the property of rubber A and B in terms of elasticity and then heat resistance. We have to explain the properties, why it is more elastic, the vulcanized rubber, and then why it has a higher heat resistance. So 6 marks here. Okay, so first we can mention, okay, point number 1. Just now we mentioned already. Okay, so point number 1, rubber A is a vulcanized rubber. Point number 2, B is the unvulcanized rubber. Okay, so 2 points already. So another 4 points we have to explain. Elasticity. Okay, point number 3, we mentioned about the elasticity. Elasticity. Okay, so becomes the point number 3. Okay, so in the vulcanized rubber, right? Okay, there are sulfur cross linkage. Okay, cross links between the rubber molecules. Molecules in the vulcanized rubber. Okay, so what is the function of the sulfur cross links here? Okay, so point number 4. Okay, when the force is applied, okay, the sulfur cross links will pull the rubber molecules okay, back to the initial position. Okay, or initial place. So that is why it is more elastic. Okay, then again you have to explain the heat resistance. Okay, heat resistance. Okay, so becomes point number 5. Okay, the presence of sulfur in the vulcanized rubber, okay, increase the size. Okay, increase of the molecular size of the rubber. Okay, molecular size of the rubber. Okay. Okay, then what is the effect? Point number 6. So more heat is needed to overcome the force of attraction, okay, between the molecule. Okay, yeah. So this is the 6 points we can write to explain the elasticity and the heat resistance of the vulcanized rubber compared to unvulcanized rubber. Okay, table shows the properties of non-hydrocarbons compound P and Q which have less than 4 carbon atoms per molecule. Okay, so 4 carbon atoms. So meaning that would be, okay, let's see again. Compound P cannot conduct electricity, do not react with magnesium, burns with blue flame. Compound Q can conduct electricity in aqueous, react with magnesium to produce hydrogen gas, and then non-combustible. Okay, so here suggest the compound P and compound Q. Okay, so here if we look at this information, can react with the metal with the metal to produce a hydrogen gas. So we know that this is actually is acid now. Acid. So acid in the carbon compounds, right? So it's a carboxylic acid. It's a weak acid. So you can choose whether it's methanoic acid, ethanoic acid, propanoic acid, because it must be less than 4 carbon atoms. Okay, so you can choose any one. Okay, then this one cannot conduct electricity, cannot react, so burns with blue flame. So this one is under alcohol actually. Okay, so here compound P we can mention whether is let's say we choose ethanol. You can choose methanol, you can choose propanol also. Okay, Q we can choose ethanoic acid also. Okay, yeah. Now state the general formula and the functional group for the compound P and Q. Okay, so you have to put two things: general formula, functional group. So let's say P. Okay, general formula will be CnH2n plus 1 OH, right? Is alcohol. So N start from 1, 2, 3, and so on. Okay. Then the functional group. Will be hydroxyl group. Okay, hydroxyl group or OH. Okay, OH. Then Q, the functional, the general formula. Okay, CnH2n plus 1 COOH. This one N start from 0, 1, 2, and so on. Okay, so the functional group. Okay, will be carboxyl. Okay, COOH. Okay. Now diagram 10 shows the reaction between the compound P and Q to produce the compound Z. Okay, so just now we choose compound P is the ethanol, compound Q is the ethanoic acid. So when compound P reacts Q with concentrated sulfuric acid, okay, it will form the nice smelling compound Z found in the fruits. So actually we know this is ester. Okay, then you need to describe a laboratory experiment to prepare the Z, and list of materials, procedure, observation, chemical equation, and then name the compound Z form. Okay, 10 marks. Now I show you a video on how to produce the ester. Okay, we put in some propanol in the test tube there, and add in 2 cubic centimeter of ethanoic acid. After that, we add in a few drops of concentrated sulfuric acid. Okay, we make it boil for around 50 minutes. Okay, then it will form the ester. Okay, so 10 marks. So we start with the material first. Okay, so what materials we need to use? Okay, so we need to use let's say just now we use ethanol now. Okay, so ethanol. then ethanoic acid. Okay, then we need the concentrated, okay, sulfuric acid. Okay, after that we need the procedure. Okay, so first steps we need to do. Okay, first one, we pour, let's say 4 cubic centimeter of ethanol into a boiling tube. Okay, we have to use the boiling tube because later we need to boil the mixture. So prefer use the boiling tube compared to test tubes. Okay, after that we add in around 2 cubic centimeter, or also we put in the same 4 cubic centimeter of ethanoic acid. Okay, into the boiling tube. Okay, and after that add a few drops of concentrated sulfuric acid into the mixture. Okay, number 4. Okay, warm or heat mixture. Okay, in the water bath for let's say 15 minutes. Okay, next. Okay, then we can collect, pour the product into a beaker containing the water. Actually, if we get directly from the test tube, they also can, but now we want to see how is the properties of the ester form. Okay, so observation number 6. Actually we can write in the observation. Observation. Okay, a fruity smell. Okay, fruity smell substance produce. And then it will form at the top layer of the water because it is insoluble in water. Okay, then after that, we have to write in the equation. Okay, so equation, we use the ethanoic acid first. CH3COOH react with ethanol, C2H5OH. Okay, so it forms the ester. So I will use the different colors, CH3CO. Okay, this one from the carbons from the ethanoic acid, so it becomes OC2H5. This one from the alcohol, then with water. Okay, so this is the equation. So what is the name for the products? The products form would be this one. It would be ethyl ethanoic is the ester. Okay, so how this is how we use the alcohol and the ester and the carboxylic acid to produce the ester ethyl ethanoic. Actually, you can, if you use a different alcohol and different carboxylic acid, you will produce a different ester. Okay, but the one you choose must be less than 4 carbons. Okay, yeah. So that is about the MRSM paper 2. If you have any question, you can write at the comment below, and then we can discuss further. Okay, thank you.